Hi, in this video, I'm going to go over how to complete the Modern Chesapeake Bay Part 2 assignment. To complete this assignment, excuse me, you'll need to find it located in Google Classroom. You'll click on your Science Google Classroom and the Classwork section, and you'll find this assignment under the Biodiversity unit titled Modern Chesapeake Bay Part 2. When you open the assignment, you'll see your directions. The directions say to open the attached Google document and analyze the diagrams to answer the questions. And you'll see an attached document that is your copy for you to edit. So you'll go ahead and open that document. When you open this document, you'll see that you have two diagrams in this document and some directions to use these diagrams to answer 10 questions on the following pages. So you have a total of 10 questions that you're going to be answering in today's lesson. Notice that you have both diagrams that we've looked at in previous classes. You have the historic Chesapeake Bay before settlers diagram, and it has a yellow background. And then on the right side, you have the modern Chesapeake Bay after the area was settled, and it has a blue background. So you easily have both diagrams to reference as you're completing the 10 questions. When you scroll down to the second page, you'll see your first question. The first question says, for the modern food web. So we know we're going to be using the modern food web to answer this question. List the number of strong and weak interactions for each of the species components at the top of this chart. Count the number of strong and weak connections, arrows going to or from a species group, to complete the chart below. So we have seafloor plants, predatory fish, grazing fish, and floating algae. And we are going to count the number of strong and weak interactions, which are indicated by their arrows, and fill in our data table. Remember, we are doing this for the modern food web. So I'm going to start with seafloor plants, and I'm going to scroll back up to my resource, and I'm going to find seafloor plants on my modern food web. Remember, our modern Chesapeake Bay food web is in blue on the right. And I'm looking for seafloor plants. And here they are. And so now that I see the seafloor plants, I need to count the number of strong and weak interactions. And so I can see one arrow leaving seafloor plants and going up, 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 up to birds. So that's one interaction. And that is a weak interaction. I see it's a dotted line, and my key tells me if it is a dotted line, it is a weak interaction. I see another arrow leaving seafloor plants and going up to grazing fish. So that's two weak interactions. And then I see another arrow going from seafloor plants up, up, up to worms. And that is also weak because that is a dotted arrow. So I see a total of 3 arrows leaving seafloor plants and going to other organisms. And all of them are dotted arrows, so they're all weak. So down in my data table, I saw 0 strong, but I identified 3 weak. 0 plus 3 gives me a total of 3 interactions. Up next, we're going to do predatory fish. So we're going to scroll up to our modern food web. Remember, our modern food web is on the right. And we're going to find predatory fish. And if you need to zoom in on your assignment, you can go to this where it says 100%, and you can make it to 125% so that you can see it even better. And so when I find predatory fish, I'm again counting the number of interactions. And for predatory fish, I can see, I'm going to start at the top. I can see one arrow going to sharks. That's a weak interaction, but predatory fish are getting eaten by sharks, so that's 1. See another arrow going from predatory fish to seals, also a weak interaction, a dotted line, but that's 2. And then I can see another line that is a solid line going from predatory fish to humans. So it's a strong interaction, so that's 3. I can see another line going from predatory fish to whales that's weak, so that's 4 interactions. And then I can start to see some lines coming toward predatory fish from predatory invertebrates, 5, from grazing fish, 6, from oysters has an arrow coming to predatory fish, that's 7, from worms, that's 8, and then I'm just going to double check and make sure that I didn't miss any. I've counted 8 interactions, and I'm going to make sure that I didn't miss any, and it looks like I haven't. So in my response for predatory fish, I counted a total of 8 interactions. Now I need to see how many of those are strong and how many are weak. And so for my predatory fish, I see all these dotted lines. The only one that is a solid line coming to or from predatory fish is the one with humans. So there's only one strong interaction, which means that the other 7 interactions are weak. So I'll fill in there's 1 strong, 7 weak. Next up, we have grazing fish. So we'll go back up to our modern food web, which is on the right in the blue section, modern, and we'll find the grazing fish. They're right here in orange. And again, we're going to do the same thing, counting their arrows. And so I'm going to start at the top, and I see an arrow going from grazing fish to the seals. That is a weak connection. It's a dotted line, but that's 1. I see an arrow going from grazing fish to humans. It's a dark line, bold line, so that's a strong interaction. That's 2. I see an arrow going from the grazing fish up behind the birds to the whales. That's 3. And then coming down, let me see really quick. Hold on. Oops. I think I see one more that's just hard for me to want to make sure. So I'm zooming in. Good. Yeah, I also see one from grazing fish to birds. So that's 4. Okay, so we've got to look really closely. We can see that arrow going from grazing fish to birds. I'm going to zoom out just a little bit now. And so I've got the one to seals, the one to humans, to birds, to whales. That's 4. And now I'm looking at my arrows coming down that are coming to grazing fish. And I see one coming from decaying matter. So that's 5. I've got an arrow coming from seafloor plants. That's 6. Another arrow coming from seagrass. That's 7. I can see over here an arrow going to sea turtles. So that's 8. Oh, excuse me. The one that going to sea turtles is from predatory invertebrates. So the 8th one comes from the predatory fish. So that's 8. And then our last one is going to be going to sharks, which will give us a total of 9. So we counted 9 interactions for grazing fish total. And we'll fill in our 9 for grazing fish. Now we need to see how many were strong and how many were weak. When we scroll up to grazing fish, notice just like predatory fish, we have a lot of dotted line arrows, so a lot of weak interactions. The only strong interaction that I see is from grazing fish to humans. I know that's a strong interaction because it is a bold arrow solid line. So we have 1 strong interaction, which leaves 8 weak interactions. Now, our last organism we're going to look at today is floating algae. So we're going to go back up and find floating algae. And here is floating algae right at the bottom of the modern food web. Remember, our modern food web has a blue background. It's on the right. And looking at floating algae, can count 2 interactions. I've got an arrow going to zooplankton and an arrow going to oysters. And looking at those 2 interactions, I see 1 dotted line, so 1 weak, and I see 1 solid line, so 1 strong. So for floating algae, I'm going to come and fill in a total of 2 interactions, and I've got 1 weak and 1 strong. So I'm filling that in my chart. Now that I've filled in my chart for number 1, I'm ready to answer question number 2. Question number 2 says, in general, do these species have more connections or less after large-scale fishing? And so we have to think back to when we looked at the historic Chesapeake Bay food web, and we can go back up and look at that one here. And looking at these connections, compare the numbers of connections that we have in our historic model with our modern model. And taking a look at that, do we see more or less, or are they similar, the number of arrows that we see? So we'll take a moment to look and consider. And we'll notice that some of the connections may have changed. For example, worms to predatory fish is now a dotted line. It used to be a solid line, but that connection is still there. And so in our response, these species have about the same number of connections. And that's what we can see from looking at those charts. Question number 3 says, how does the strength of the interactions compare between the modern food web and the historic food web? So they have about the same number of arrow interactions, but what about the strength? Remember, strength is indicated by the arrow. If it is a strong interaction, it is bold and solid, and if it is a weak interaction, it is a smaller dotted line. So when I'm analyzing these 2 graphs, I've got my historic and then I've got my modern on the right. I see a lot more strong, bolded arrows in my historic food web. My modern food web has a lot more weak interactions with dotted line arrows. So that is what I'm going to put for my answer to number 3. The strength of interactions has decreased in the modern food web. There are weaker interactions in the modern food web compared to the historic. And so we've answered question number 3. Next, question number 4 asks us, how is the modern food web similar/different to the historic food web without humans? So first, we're going to put in similarities. So we're going to scroll up and analyze the 2 food webs, and we're going to see what is similar between them. And so we might notice that there's several of the same organisms in both food webs. We've got jellyfish, we've got birds, we've got seals. So several of the same organisms exist in both. We can also notice that birds are abundant in both because birds are solid colored in both. And if it is a solid dark color filled in, then we know that it is abundant. Another similarity is that the number of interactions has remained the same, even though the interactions are weaker in the modern food web. So we'll come and we'll put down some of those similarities we just mentioned. The food webs are similar in that they Both contain many of the same organisms. Birds are also abundant in both. They also have similar number of interactions. So there we've put our similarities. And I will separate that out with bullet points. So that we're able to see them clearly. Next up, we have our differences. So how are these food webs different? So looking at my historic food web compared to my modern food web on the right, I see that my historic food web had much more abundant organisms. The circles were more solid, colored, and darkly filled in the historic food web model. Alligators, sharks, seals, whales, birds, grazing fish, predatory fish, sea turtles, all of those were abundant, and now most of those organisms are rare in the modern food web. Another difference that I see between them is the strength of the interactions. In the historic food web, many of the interactions were strong, noted by their solid, bold arrows, compared to the modern food web, many interactions are weak, shown by their dotted line arrows. So I will come and put in those two differences as my answer. The historic food web had more abundant organisms. The historic food web had stronger interactions compared to the modern food web, which has more rare organisms and weaker interactions. So we have answer number 4, and now we're ready to answer question 5. Question number 5 asks us to look at jellyfish. Why do you think jellyfish are now abundant in the modern food web? When we scroll up to our modern food web and find jellyfish, here they are, they're abundant. They have a dark circle indicating that there are a lot of jellyfish in this ecosystem, and we need to analyze and think about why are jellyfish now more abundant. And so looking at this food web, I can see that the two organisms that consume jellyfish are sea turtles and whales. And when I see that sea turtles and whales are the two organisms that consume jellyfish, I notice that compared to the historic food web, sea turtles and whales used to be abundant. That means there used to be a lot of sea turtles and whales. But now, sea turtles and whales are rare. I know that they're rare because their circle has an outline that's only lightly shaded in. So that means that there's a lot less sea turtles and whales than there used to be. So if there's a lot less sea turtles and a lot less whales, then jellyfish are not getting eaten as much by the sea turtles and whales. So for my answer to number 5, jellyfish are now abundant because there are less sea turtles and whales to consume them. And there I've put in my answer to number 5. Keep going. We have 5 questions left. So here's number 6. Number 6 says, which producers are now more abundant in the modern ecosystem? Floating algae or seafloor plants and seagrass? So which one is more abundant? Floating algae or seafloor plants and seagrass? In my modern food web, my producers are down at the bottom. I can see them in green. Seagrass and seafloor plants are both lightly shaded in, so they're rare. Floating algae is darkly colored, darkly shaded in, which our key tells us that means it's abundant. So my answer would be floating algae is more abundant. The producers that are more abundant are floating algae. Now we're ready for question 7. Question 7 says, think back to our watershed model. From what you know about the relationship between high levels of nutrients and fertilizer and algae growth, why have floating algae increased? So this question is asking us, why are floating algae now more abundant in the ecosystem? They used to be rare in the historic model, so why are they now abundant in the modern food web? If we need extra help, here is a help link video. We can click on the link and when it loads, it will be a 2-minute video reviewing dead zones with us. Now you can watch this video on your screen to find out how to answer question number 7. Again, question number 7 wants to know, why have the floating algae increased? Pause the video of me, watch the help link video, and then put your answer. I have typed in my answer to question 7. Floating algae have increased because there are more nutrients from the runoff providing energy for growth. So this is the runoff, the fertilizer has increased the number of floating algae as it has provided nutrients for the floating algae to grow and become abundant. We have 3 questions left. Question number 8 says, in addition to runoff, what other cause is affecting the increase in floating algae? Use the food web to consider other organisms that floating algae interact with and to explain what happened and why. So we need to look at our modern food web and see what else is causing there to be an abundance of floating algae. Now, when I look at my food web and I find floating algae, I see floating algae is abundant. It is a dark circle. Floating algae gets consumed by 2 organisms. Floating algae gets consumed by zooplankton and oysters. Zooplankton and oysters were abundant in my historic food web, but now zooplankton and oysters are rare. Why are oysters rare? Notice that oysters have a strong connection with humans. Humans are fishing oysters, causing oysters to be rare. With less oysters and with less zooplankton feeding on the floating algae has become abundant. So now we'll type in our answer to question 8. Humans are fishing oysters, which have caused the oyster population to decrease. Less oysters are feeding on / interacting with floating algae, which is causing there to be an increase in floating algae population. There I have described the relationship between oysters and what has happened to additionally cause an increase in floating algae. Up next, we have question 9. Based on your response to question number 8, Develop a question to investigate the cause and effect relationship between oysters and floating algae. So we need to come up with a question. What question can we investigate to find out more about this relationship between oysters and floating algae? Think about what questions we could investigate. Questions usually begin with what, how, why, when. One example of a question that we can investigate to find out this relationship between oysters and algae could be, how does the number of oysters affect the number of floating algae? Your question may be similar, but it may be a little bit different. As long as your question is investigating the relationship between oysters and floating algae and how there is a cause and effect in that relationship, then your question is good for investigation. Question number 10 asks us, what type of data would you need to collect in order to answer your question? Think about the types of data you analyzed in earlier lessons. What variables should be considered? My question, how does the number of oysters affect the number of floating algae, would ask me to look at data of the population of oysters and the population of algae over time. Data that I need to answer my question would include the population of oysters and floating algae over time. Particularly, we have been analyzing modern and historic food webs. Modern and historic data would be helpful. Now that we have answered question 10, we're done. We should review our work. And after reviewing to make sure we've answered all of the questions, we'll turn in our work. If you still have questions about how to complete this assignment after watching this video, please reach out by commenting on your assignment or sending an email.